In the center of Beijing lies a daring new design. 42,000 tons of steel beams woven together into the shape of a bird's nest. It's the stunning vision of an international team of architects and engineers. And it takes center stage in one of the biggest events of the decade, the 2008 Olympic Games. Come inside Beijing's Olympic Stadium. It's early morning in China's capital, Beijing. Today, workers must raise a gigantic mass of twisted steel to the top of this structure, 70 meters in the air. It's the last piece of the puzzle to complete the steel skeleton of this unusual arena. Its steel roof is 320 meters long and 297 meters wide, and covers a massive bowl that seats 91,000 spectators. It is the largest stadium ever built in China. And it is the center of the biggest sporting event in Chinese history, the 2008 Summer Olympics. But even more impressive than its sheer size is its unprecedented design. It's an ambitious plan that calls for giant curving beams, which crisscross in an intricate pattern of woven steel. They give the building its nickname, the Bird's Nest. No building like this one has ever been attempted before in the world.
As the design evolved, it was quite clear that it was going to be a major challenge to engineer it and to fabricate it and to assemble it. It is very, very complicated.
This one, with its twists and turns and complications, is certainly one of the ones that's way out on the edge. First of its kind in China, first of its kind in the world.
The steel structure of bird's nest is so huge. Maybe it is one of the biggest steel structure in the world. In the future, I will not see any other projects more difficult than this bird's nest.
The Bird's Nest must have all the bells and whistles of any Olympic stadium. Giant screens, shops, and great views of the field. But it also faces some unique challenges. It sits right in the middle of a seismic region. So the fragile-looking design must be strong enough to withstand dangerous earthquakes. And it must be eco-friendly. In a city with massive air pollution, officials have mandated that this Olympics be the Green Olympics. To fit this green mandate, the steel roof is skinned with high-tech membranes, which let in sunlight to conserve energy, keep the noise in, and the rain and wind out. State-of-the-art systems conserve energy and water and regulate heat. The building's facade isn't enclosed, allowing natural ventilation. The radical design meant new building techniques would have to be invented, all while up against the immovable deadline of the 2008 Summer Olympics. It was a huge challenge.
We have so many pressure. So this pressure also a very big challenge for me.
The challenge begins in July 2001. Beijing is in the final running to be the Olympics' next host.
The Games of the 29 Olympiad in 2008 are awarded to the city of Beijing.
It's a badge of honor for every nation, but has even greater significance for an emerging modern power.
The most important thing is that we know that we are accepted by the world.
But as the citizens of Beijing celebrate, the city planners begin to worry. there are few venues up to par for the prestigious sporting event. China must design and build new sports arenas, and fast. To make space, traditional alleyways called hutongs must be torn down, a piece of history lost forever. It's controversial, but some think the building boom will bring benefits to the city.
They have improved so much of the infrastructure. This is actually about an Olympics acting as a catalyst for the regeneration of Beijing.
Over the next 7 years, 12 Olympic venues will need to be built, along with new high-rises, roads, public transport, and even a new airport terminal to accommodate the thousands of Olympic guests. Construction projects that will radically transform Beijing's skyline. For the Olympics' main stadium, the city wants a stunning design worthy of the event. In 2002, officials announced a global competition. Among the dozens of entrants are Swiss architects Jacques Herzog and Pierre de Meuron. They're drawn to the challenge of working in Beijing.
This was the opportunity for us to do a major building in Beijing, which was really public, really a new place. China's about to get back to where it once was, to become the most influential culture in the world. To be part of that energy is another amazing moment in our lives.
The Pritzker Prize-winning architects are best known for converting London's Tate Modern Museum. They've also designed other sports venues, such as the famous Allianz Arena in Munich. But this job is one of their most challenging yet. They have no idea how the Chinese will react.
There are differences to our Western ways of thinking. And to discover this step by step is a marvelous personal experience. And that brings you back to the Chinese way of doing things.
They decide to consult one of China's leading artists, Ai Weiwei, who inspires them to push the limits.
They are very different from all the architects I know. They would start it from zero. There's nothing in their mind when they start.
He was always encouraging us to go beyond this or that, but to really take this as a chance to do something that couldn't be done somewhere else.
They come up with a concept inspired by old Chinese art, with sweeping lines arranged around a circular vessel.
We were clear that we wanted something else, and it should be really an object for the people, but something which has more a character of like a big pot or a big vessel for people to go in.
But though the inspiration is ancient, the team wants the building to be a contemporary icon and a public space for the people.
A new place, like perhaps comparable to Paris, the Eiffel Tower, which was also made for an event, but then became an icon of the city. The idea was much more this idea of the membrane, of something which has a kind of inviting quality, the way people can go in and go out. The space, especially where people can entertain themselves. They can dance, they can sing, they can tai chi, they can use the space. And the Chinese people love to do that. They use public space. And that's perhaps also what makes the stadium really Chinese.
But the architects need to do more than just come up with a stunning design. They need to be confident that it can be engineered into an Olympic arena. They team up with engineering experts from Arup in England and China's Architectural Design and Research Group.
It should be a building you've never seen before in the world.
Together, they refine the plans to win the commission and collectively hold their breath. In April 2003, the jury cast the vote. Out of 13 finalists, Herzog and de Meuron's daring design is chosen to be the Olympics' main stadium. The Chinese say it looks like a bird's nest, and the nickname sticks. The ambitious design comes with a hefty price tag, 3.5 billion won. The city designates 3,000 acres of land for the Olympic Park, surrounding the bird's nest. It'll sit on an important site, at the north end of an ancient and powerful line, known as the Imperial Axis, that connects the gates of China's cultural monuments, Tiananmen Square, and the Forbidden City. Now the line will intersect the main stadiums of the Olympics, the Bird's Nest, and its sister stadium, the National Aquatic Center, nicknamed the Water Cube after its design, a blue transparent cube covered with water bubbles.
They want, in the developing area of Beijing, a contemporary building as a symbol of the Beijing Olympic, as a symbol of New Beijing.
The bird's nest design is unlike any other on Earth. But now, they've got to build it. With the strictest of deadlines looming, the opening ceremonies in summer 2008. On December 24, 2003, construction on the Bird's Nest Stadium kicks off with the groundbreaking ceremony. And the countdown begins. Within a few months, workers are ready to pour the concrete foundation. But right from the start, engineers need to confront one of the major challenges of building in Beijing. China is surrounded by some of the deadliest fault lines in the world, and the stadium must be earthquake-proof. In 1976, a magnitude 7.8 earthquake hit the city of Tanshan, not far from Beijing. It ravaged the city, killing 250,000 people. It was the deadliest earthquake of the 20th century.
The basic problem with earthquake design is that the building is just so large that what's going to happen at one end of it might be different from what's happening at the other end at any moment in time. So it's not just going to shake very happily together in exactly the same frequency and exactly the same time.
Such shaking can cause severe damage to rigid buildings like those made with concrete. They decide to build the steel frame as a separate structure without touching the concrete bowl within. If the concrete were to crack in a quake, the steel frame would be unaffected. They also divide the bowl into 6 isolated sections that can move independently.
And we'll have flexible zones between them, flexible joints between them, and there's quite a large gap between each of those sections. They can then move independently if there's an earthquake. So, for instance, one corner of the stadium would be able to wobble in one way, and the center and the section alongside might be able to move in another way. And by doing this, we can allow the building to absorb the energy of an earthquake without shaking itself to pieces.
If an earthquake strikes, the shaking of the parts won't collapse the entire stadium. But working in an earthquake zone isn't the only challenge. Designers have to satisfy the strict guidelines of the Olympics. The stadium will need to have high-tech systems, giant screens, and world-class seating with great views of the field. Coming up with the interior design plan falls to the British partner, Arup. Jay Parrish has been designing stadiums for 30 years, from the inside out.
The very first step of designing the building was to look at its heart. The seating bowl, we looked at forms that the stadium bowl could be. Where are all the seats? How are they arranged? How much space do we give people? What quality of view do we set? And it then generates the overall form of the building. It sets the heights of the concourses, it sets the balance of facilities. Where do we have premium facilities? Where do we have general facilities? Where's the VVIP box? How do we put in the giant screens? All the things that you have in a typical stadium.
Using state-of-the-art technology, Parrish calculates the seating arrangements in the concrete bowl to make the most efficient use of materials and space. And above all, to ensure that spectators will enjoy watching the event. Each seat will be as close to the action as possible, with no seat more than 142 meters from the center of the field.
I think people are going to find very unusual for a building this size is the sheer intimacy that they're going to experience when they're inside the bowl and they're watching events. We worked really hard to generate that atmosphere and that excitement.
With the design phase complete, the work on the concrete bowl can finally begin. By May 2004, construction is underway. But it doesn't get far before an unexpected catastrophe strikes. On May 23, 2004, at Paris's Charles de Gaulle Airport, the daring new Terminal 2E suddenly collapses with no warning, just 1 year after its opening. First, 2 cracks appear inside the terminal wall. Then, a piece of concrete falls off. Just minutes later, the ceiling crashes to the ground. It kills 4 travelers. By coincidence, 2 of them Chinese. The fatal collapse shocks the engineering profession, but it hits home even harder in Beijing. The terminal roof had a similar design to the bird's nest, without interior supports. The tragedy hangs over the heads of the bird's nest team, and they worry about how this will affect their building.
It was a difficult time for all of us, and we had, to prove in many kind of expert panel meetings that our building is safe, design meets all the standards.
At the beginning, we worry a lot.
Their worst fears are realized. China suspends all work on the bird's nest. Beijing's officials re-examine the safety of the bird's nest design.
就是法国机场那个事件呢，对我们这项目呢，也敲了一下。
The French airport incident was a wake-up call for us. We organized experts to conduct verification. We did some real testing.
这个项目呢，再进行这个。
The retractable roof, amounting to 1/8 of the cost, is put under the most intense scrutiny. As the team awaits the result of the review, the weeks turn into months. With a tight construction schedule, any delays could be disastrous.
I was anxious because if we failed to reach this particular milestone on time, then it was likely that the Olympic Games would have to be postponed. For us, this would be a horrifying scenario.
After 5 long months, the officials finally give the go-ahead to continue the work, but reduce the number of seats and cancel the original retractable roof design, concerned about costs as well as safety. Working with the officials, the architects redesign the stadium. They come up with an open-air design that retains the shape and style of the original. It makes the stadium cheaper and safer, but also more eco-friendly, since it will require less steel. They're back on track, but time is not on their side. The Bird's Nest team must finish the bowl before the winter hits, or the concrete will freeze. Henry Zhang of the National Stadium wastes no time and assembles thousands of workers. The construction accelerates.
We put in 7,000 people working around the clock in 3 shifts a day.
The crew must force the concrete to defy gravity. It needs to be pumped up from the bottom of the forms. through reinforced steel beams which strengthen the concrete. But the thick wires are slowing them down, and they still have 4 floors left to go. With less than 6 months before winter, hundreds of tons of concrete must be poured at the site. By November 15, 2005, in just 5 months, the bowl of the bird's nest is complete. Just in time before winter's deep freeze. Just 2 years after the first ground was broken, the concrete bowl is finally ready for its daring outer facade. For the Olympic Stadium team, the most challenging part of the construction is about to begin. Building the steel structure that makes it the bird's nest. October 28, 2005. The first steel pillar is ready to be hoisted into place. Before the team could get to this point, engineers had to first solve a fundamental construction riddle: how to weave 42,000 tons of steel into the shape of a bird's nest. Arab Sports specializes in designing sports venues, but they've never made anything quite like this one.
Right from the start, we were thinking, well, how do we build this? How do we create these elements?
The architect's plan calls for massive beams that twist and turn around the 300-meter-wide stadium. It needs to look random to create the bird's nest illusion. But at the same time, the beams have to support each other and carry the heavy loads safely so that this artistic vision can stand on its own. The design is so complex that paper blueprints aren't sufficient. Engineers have to turn to aerospace software to build up a 3-dimensional picture to organize the beams.
I don't think that this would have ever taken shape if anyone had to design this on paper with a slide rule. This building exists because of computer-aided design and the new abilities to use computer models and to be able to feed computer data over into the manufacturing sphere as well.
The first set of beams is on the outside. 24 pillars in the form of trusses encircling the concrete bowl. They serve as the bones of the structure. Just like a human skeleton, this backbone keeps the building from falling down. But in the case of the bird's nest, the skeleton is on the outside and is also the building's facade.
You can take as an example, you can take old cathedrals which are made out of stone. There, the outside, the inside, the structure, the space is one unit, so to speak. There's something of that echo at the National Stadium. It gives you a much more powerful idea of space.
A second set of beams fills in the empty spaces between the beams in the first set, like the tendons in a human body that hold the bones of the skeleton together. They link all the beams to form a braided structure.
It's like 24 people holding hands, 48 arms linked together.
A third set of beams supports the stairways that connect the multiple levels and provides a frame for the roof membrane covering.
Its main purpose is to break down all the gaps that you get between the structure and the second system into areas that are small enough that we can put the roof.
When seen from the sky, the interlocking beams give the stadium its bird's nest illusion.
It's a brilliant description. The impact that it has when you see it is one of very organized chaos. It's really rather delightful.
But this revolutionary design places unusual demands on the beams. The beams must physically twist and curve as it wraps around the stadium. Before construction can begin, the team must make sure the steel is strong enough to bear the load, especially around the curved edges, where it has the most twist.
They climb to the top of the building, and then they change direction. It's almost a right angle. And then they cross the stadium, and then curve back down again.
That's over 300 meters from one end to the other, wrapped around with the same side up at all times. Once again, the team will have to try something new. Engineer a special steel, strong enough to handle the stress of the curves, yet flexible enough to withstand earthquakes. The Bird's Nest team revisits the seismic tests to refine their steel design. How strong the steel needs to be, how thick the plates, how big the welds. Arab structural engineer Michael Kwok creates computer models to study how severe shaking might distress the structure.
This is effectively simulating the worst event that could happen in Beijing.
After dozens of scenarios and some number crunching, they calculate the right flexibility for the steel. Steel is a dream material for architects. It can be easily customized to fit any need. Add carbon for strength or iron for flexibility. The Bird's Nest will need both to support its 42,000 tons of steel. The team creates a brand new steel for the Bird's Nest called Q460, never before used in China.
It's very meaningful because it's made in China, a unique steel product produced by China's own steelmakers. We had to conduct many experiments to develop the technology.
The newly engineered steel will stand up to Beijing's earthquakes.
It is designed specifically for the codes for Beijing. The Bird's Nest can wobble quite happily, and the flexibility of the steel will allow that to happen without it damaging the structure. We never know just how strong an earthquake's going to be, and at the moment, we generally don't know when they're going to arrive. If there is an earthquake, let's hope the building behaves very well.
But for the construction crew, the challenges are just beginning. They still have to build it. The task will be more complex than anything they've ever attempted.
There are several thousand components to the Bird's Nest structure, of which only 2 are the same. All the others are different. We noticed there wasn't a single straight beam. We started to worry that if we couldn't give the real beams exactly the same curve as those in the models, what would the finished project look like?
Creating the curved beams will require some ingenuity. The engineers come up with a box design to create the right aesthetic and to bear the heavy loads. 4 steel plates, 1.2 meters on a side, are bent into the required shape and welded together to form a twisted box section.
It's actually like the world's biggest jigsaw. Well, they've been cut out to particular shapes, which are not simple rectangles.
These puzzle pieces will be assembled to create the Bird's Nest. But first, the team must move them from distant factories in Shanghai to the Bird's Nest construction site. The trucks must cross 6 cities and 5 provinces. Once on site, workers weld the boxes together to form even larger sections, forming a truss, some of them up to 12 meters long. Then, an 800-ton crane hoists the beams to the top. Positioning the massive sections up to 350 tons requires great skill.
It's very difficult to fit all the parts to these butt joints without any error. You sometimes found that in positioning one joint, another had gone out of alignment.
Finally, they will spend 2 or 3 days of welding the joints to secure them in place.
An incredibly complex task, and you've got to remember that much of it is carried out 20, 30, 40 and more meters in the air as well.
The welds must be perfect, for they will hold the steel structure in place. Over 1,000 skilled welders are trained for the job. Hu Kui-li from the Hunan province was one of them.
I came to work here in July 2005 as one of the first group of welders. I was at a training course when I was told I'd be working on the Great Bird's Nest.
Kui-li spends most of his time at the highest point, on the roof, 70 meters above the ground, and lives with a very real danger of falling to his death. Despite safety measures, at least 2 workers are accidentally killed during construction. It's slow, difficult, and uncomfortable work. The Q460 steel is extremely hard and must be heated to over 100 degrees centigrade, much higher than normal. And the welding areas are difficult to reach.
The bird's nest requires special welding. Some positions are challenging. Sometimes the welders have to work lying on their backs for 14 to 17 hours. You can imagine how they must feel after working for so long in such a position.
It takes a full day to weld a meter-long seam, and there are 320 kilometers of them. After a year of back-breaking work, all the beams are in place, but not all the seams have been welded together. A few were left open to release stress caused by different temperatures during construction. The remaining holes must be welded before the bird's nest will be one seamless structure. The work will be harder than usual, and they will have to weld the seams at a relatively constant temperature. That's because steel expands and contracts.
When the temperature rises, so does the bird's nest. And when the temperature falls, the bird's nest settles again.
The carefully welded seams must hold up throughout Beijing's dramatic weather shifts over the seasons for the life of the building. So the open seams in this massive structure must be welded at the midpoint on Beijing's temperature scale. In the heat of the summer, the welding must take place at night. And it must be welded at about the same temperature. Over 3 nights, the welders will have to work without a break.
So they had to sleep and eat well beforehand. We had to work out a detailed schedule for the welding work. Otherwise, the welders wouldn't be able to rest and eat properly.
August 26, 2006. At the stroke of midnight, more than 400 welders begin work on the night shift. The first night is a success, but on the second night, the team gets unexpected news. Weather forecasters predict a storm will roll in. If it hits Beijing, the carefully calculated plan will be compromised. The team stands on edge as experts monitor the storm. Luckily, the rain moves off course and doesn't make it to Beijing. A crisis is averted, and the welding work is completed without a hitch. On August 31st, welders finish closing the steel structure. Now the bird's nest can expand and contract, or breathe. The workers who helped build the bird's nest are proud of their accomplishment.
The bird's nest is the first major project I've ever worked on. The welders working on the bird's nest were like tailors. We sewed the bird's nest together bit by bit. We all agreed when we were taking the training course that when the bird's nest was finished, we'd carve our names onto a steel plate and bury it in the ground. We'd erect a big stone memorial tablet.
Just 10 months after the first beam was raised, the bird's nest steel structure is now won.
This 1 year felt like 10 years to us. It was very long. That was how we felt.
With the seams welded, the team must now remove the bracing. It will be the stadium's big test, a major turning point that will spell success for the building or an unthinkable disaster. September 2006. After 3 years, the Bird's Nest team is about to face the greatest challenge of their careers, making the Bird's Nest stand on its own. Until now, the building has been on crutches. 78 support columns evenly spaced out around the stadium temporarily support its 42,000-ton mass of steel. Now, in a process called the unloading, the team must remove them before the steel structure will stand by itself. It will take 1 week. The operation is about to begin.
This is a very decisive moment in the whole construction process. You know, the whole structure is standing up. And if the calculation of the engineers were correct in the end.
This steel structure is the part we were most uncertain about, since there was no prior experience to learn from. So we were very worried.
A lifting jack will lift each beam and temporarily bear the heavy load of up to 300 tons. When the supports are removed, the jacks will slowly descend. The main structure will sink into itself up to 30 centimeters. It's all part of the engineer's plan. Now, the team holds its breath for the result. If it sinks further, or any cracks appear in the steel, it's a signal there are serious problems in the design or construction. The operation is carefully choreographed, but the team is anxious. And they've got a big audience. The unloading is broadcast as a live report on Beijing's central television station, BTV. The engineers monitor the process.
Very anxious to see what the final reading will be in terms of this and how the structure will settle.
The process is excruciatingly slow. The hydraulics go up. The supports are removed. And the commander gives the signal to lower the jacks. Slowly, they descend. The steel sinks, millimeter by millimeter. They must do this in 35 steps until finally the steel skeleton of the bird's nest bears its own weight. After 1 week, the team removes the final support.
The last column taken off, you know the feeling.
It is exciting, that moment when the structure has taken shape and the thing that you've been working on for so many years is now a reality, and there it is, and you go, wow.
At 11:10 a.m. on September 17th, freed of its supports, the steel settles into its final position. As the stress is redistributed, the bird's nest sinks a whopping 26.5 centimeters into itself. At long last, it stands on its own.
It's like a baby could run or walk by himself without his parents. You realize bird's nest has become a real huge building in China. That's the moment.
The design has held up. The construction is a success. The bird's nest has entered its final stage. But there's no time to relax. There's much to do before the building is complete. The stadium remains a hollow steel shell, and it must be fitted with the features that will make it an Olympic stadium. Like high-tech screens, concourses, shops. The countdown clock in Tiananmen Square is a reminder for locals and visitors. Citizens eagerly follow the progress. With the Olympics just 1 year away, the excitement in the air is palpable. During the last Olympic Games in Athens, construction was running behind schedule. It was a race against the clock to complete the venues before opening day. Beijing doesn't want to make the same mistake. Fall 2007. Beijing's National Stadium is in its final push to the finish line. The team must complete the last bit of construction, skinning the roof. Just as birds fill in the spaces in their nests, workers will have to fill the spaces between the beams of the bird's nest stadium with a transparent membrane called ETFE. For the workers doing the installing, it's challenging. The seemingly random pattern of beams creates spaces that are irregular, with lots of different shapes and sizes. And workers must fit them the old-fashioned way, by hand. They must be careful, as they could easily slide off the curved edges, and they can't be afraid of heights. This membrane provides rain and wind protection. It also saves energy. Sunshine filters through the roof to light the building. The construction is on track, but a bigger problem is on people's minds. The building boom is coming at a price. Over 100 new cars hit the road every day, and traffic is often at a standstill. Olympic officials are concerned about the air quality in Beijing and wonder how it might affect athletes' performances in an open arena. The city must do everything it can to combat the pollution, so Beijing spends $12 billion to move industrial polluters, plant hundreds of trees, and reroute traffic. With the world watching, Beijing's mandate for a green Olympics is put to the test. The bird's nest must also pass its real-world trials. From its network of green systems, like the geothermal heating and rainwater capture system to feed the grass on the field, to its state-of-the-art electronics to broadcast the action around the world, and the cutting-edge lighting system with different settings for different occasions. The architects and engineers must make sure each functions in sync and see the stadium systems come together. In April 2007, architects Herzog and Demeron return once again to the bird's nest to check on its progress. Their vision now stands before them in steel and concrete.
This is clearly my impression that this is so much more powerful and so much more elegant. The silver, the black, and this more brown Chinese red was fantastic.
The sight of the real thing surprised them.
I saw his astonishment when he set eyes on it.
这个钢结构这么真实的建造起来的那种定义。
I wasn't satisfied with the welded seams and the smoothness of the steel structure.
它那种平滑度啊，我都觉得还没达到我的要求呢。
I'd found many faults, but he brushed them aside as trivialities.
他已经不在乎这些小毛病。
Such a great building has been built in China, with Chinese technology, Chinese products, and Chinese workers. I feel really proud.
The most amazing thing is that it was really realized exactly how we wanted. So if you don't like it, it's because we messed it up.
The stadium will become part of the memory of the Olympic in Beijing in China. We say New Beijing, New Olympic. I think Bird's Nest could become this symbol.
I think when the building comes to life, everyone involved will be elated. Personally, I think this is a good building. I like it as I like my own child. To be part of it, I feel proud and very honored.
For Li Xinggang, it's been a long 6 years of his life.
I worked for this project. I was 33 years old to 39 years old. I worked from a young man to a middle-aged man for this project.
After 6 years of grueling schedules and hundreds of thousands of man-hours, 42,000 tons of concrete and steel are designed, engineered, assembled, and welded into place.
The opening day, I think I will be inside the stadium together with all the people. Yeah, that will be an exciting night.
And the Bird's Nest is ready for its final debut.